Ever wonder how a star, much like our own sun, comes to be? It all begins in a nebula, a vast swirling cloud of dust and gas. Suspended in the seemingly infinite expanse of space, these nebulae are the cosmic nurseries where stars are born. Over time, the nebula's own gravity pulls it inward, causing it to collapse on itself. As it contracts, the pressure and temperature at the core of this cloud begin to rise dramatically. This is the crucible in which a star is forged. A protostar, the earliest stage of a star's life, is born amidst this cosmic turbulence. Still gathering mass and growing hotter, this infant star is on a journey towards stability. And then, the magic happens. The protostar reaches a point where nuclear fusion commences, igniting the star's core, releasing light and heat, and marking the birth of a new star. Once a star is born, it enters a phase known as the main sequence. What exactly happens during the main sequence phase of a star? Well, the main sequence phase is where a star truly shines, quite literally. This is the longest period in a star's life cycle, where it spends the majority of its time. It's kind of like the star's career, if you will. During this phase, a remarkable process known as nuclear fusion takes place in the star's core. Here, intense pressure and temperature cause hydrogen atoms to collide and combine, forming helium. This process is not just a stellar chemical reaction, it's the star's power source. The energy produced from this fusion is so immense it gets released in the form of light and heat. This is the reason stars, including our very own sun, radiate light and warmth, making them the luminous celestial bodies we see in our night sky. But nothing lasts forever. Not even for stars. Eventually, a star exhausts its hydrogen fuel and ventures into the next stage of its life. What happens when a star runs out of hydrogen fuel? A wonderful question indeed. This brings us to the red giant phase, a period of transition and transformation. As the star exhausts its hydrogen reserves, a new fuel takes center stage: helium. The helium-burning phase causes the star to inflate, much like a balloon. Imagine a celestial body, once relatively compact, expanding to a size that could swallow planets whole. Quite a dramatic growth spurt, wouldn't you say? This expansion isn't without its distinct visual flair. Our star, once a bright white, begins to change. It starts to glow with a deep red hue, hence the term red giant. This reddening is a result of the star's surface cooling down, even as its core temperature soars. So, what's next for our red giant? Well, as with many things in the universe, the fate of a red giant depends on its mass. How does a star's life end? This is a question that has fascinated humanity for centuries. Stars, much like living beings, have a life cycle. They are born, they live, and eventually they die. But unlike us, their death is not a quiet fade into the dark. No, it's often an event of cosmic proportions. Let's start with the low-mass stars, those that are similar to our sun. As they exhaust their nuclear fuel, these stars swell up, becoming red giants. They shed their outer layers, leaving behind a dense core. This core is what we call a white dwarf. It's about the size of Earth, but it's so dense that a teaspoon of it would weigh as much as an elephant. Over billions of years, this white dwarf cools and dims, eventually becoming a black dwarf. It's the stellar equivalent of a glowing ember slowly fading into the night. Now what about the high-mass stars, those that are at least 8 times the mass of our sun? Well, their end is a bit more dramatic. When these massive stars run out of fuel, they don't just gently fade away, instead they go out with a bang. A supernova, to be precise. In a supernova, the star's core collapses under its own gravity, causing the star to explode. This explosion is so powerful that it can outshine an entire galaxy for a brief period. The remnants of this explosion can lead to the formation of a neutron star. These are incredibly dense objects, even denser than white dwarfs. If the star was massive enough, the core's collapse could even create a black hole, an object so dense that not even light can escape its gravitational pull. So, as we see, the death of a star isn't a simple, peaceful event. It's a spectacular, violent process, a cosmic fireworks display that can lead to the creation of new stars and galaxies. It's a reminder that even in death, there is life, there is creation. A star's death can be a spectacular event leading to the birth of new stars. So, how does the life cycle of a star unfold from birth to death? From the depths of a nebula, a star is born. Nebulas, these colossal cosmic nurseries, are filled with gas and dust. Under the influence of gravity, these particles begin to clump together. As these clumps grow denser and hotter, a protostar forms, marking the dawn of a star's life. But the journey is just beginning. As the protostar continues to accumulate mass, the pressure and temperature at its core rise. When these conditions reach a critical point, hydrogen atoms begin to fuse, producing helium and releasing energy in the process. This is nuclear fusion, the heart of a star. With this, our star enters the main sequence phase, the longest stage in its life cycle, where it shines bright, stable, and steady. Yet even stars can't escape the march of time. As the hydrogen in the core depletes, the star starts to expand and cool, transforming into a red giant. This grand phase sees stars like our Sun expanding beyond their original size, their outer layers stretching outward, their color shifting from white-hot to a brilliant red. The death of a star, however, is a spectacle in itself. Smaller stars like our Sun will shed their outer layers, leaving behind a hot core known as a white dwarf. This will eventually cool and fade into a black dwarf. Larger stars, on the other hand, meet a more dramatic end. When they exhaust their nuclear fuel, they collapse under their own gravity, triggering a supernova explosion, an event so bright, it can outshine an entire galaxy. So there you have it. From humble beginnings in a nebula, through the steady shine of the main sequence, the grandeur of the red giant phase, and finally to the star's dramatic end, this is the life cycle of a star. Whether it ends with a quiet fade or a spectacular explosion, each star's journey is a story of cosmic evolution. The life cycle of a star is a fascinating journey, a testament to the wonders of our universe.